Right, so I made a tutorial on getting lightning in between objects based on proximity, and I also promised I would make two more tutorials, one about getting lightning across towards a part so that you have more control over it, and also getting lightning to arc within a single object. So this is that second tutorial where we're just going to talk about how to get lightning across a path, how to make it look good, and yeah, so let's just jump right into it. So now here I'm in Blender 3.1, this is important, won't work with earlier versions. And the first thing I'm going to do is I'm going to spawn in a curve with Shift A, going to curve and spawn in a Bezier curve. Alright, I'm then going to edit this curve a little bit so that it's not exactly lying on the world center, and I will just nudge it into a more comfortable shape, and I will go into my GeoNode setup. It might look different from you, from your setup, but just make sure you have a Geometry Nodes editor opened anywhere. You do that from these buttons up here, they're on every window. And yeah, let's get right into it. To add a geometry node, the first thing you want to do is click this new button. There we go, now we're basically good to go. And first off, we're going to want to resample this curve, because currently this curve only has 2 control points. If we go into edit mode, we will see that, but we need a lot more, so we will resample based on length, which means the longer the curve is, the more points we get. And I would set this up to be something high, like 1 meter. And we'll notice this jankiness, which is not desired, so we don't want to go too low. I maybe overdid it over here. Make sure that in your object data properties the resolution preview of your curve is maximum 64, because otherwise there's some discrepancy with the way Blender previews curves and what is actually getting resampled here. So anyway, let's just set it to something like 0.3 and talk about what we're actually going to do next. So the first thing is we're going to want to add some noise to this curve, and basically this is going to be a big noise, big scaled noise. So to do that, we're just going to set position, which allows us to set the position of every point on this curve, and we're just going to use a noise texture. Now the noise texture gives us a color output, which sadly, since it's a color, it contains the values 0, 0, 0 all the way to 1, 1, 1, which is not very good, because a vector, in order for it to go in every direction, it needs to be from -1 to 1. So in order to do that, we're just going to shift everything with 0.5, and that will basically center this randomness around -0.5 all the way to 1 for every value. Okay, so that's what we're going to do, and we're going to do this using a vector math node. Let's go ahead and plug this in. Let me just clear my doodles. Plug this in using a subtract node, color into here, subtract 0.5, and that will basically help center our noise. And then we are going to plug this into the offset, which will offset every point by this amount. Now we just halved the strength of this noise, so we're going to want to bump that up again using another vector math, set to multiply. And now we can see that we can change the scale of this noise as we please. For this noise, we're going to want to set roughness and detail to 0, and then give it a very low scale, something like 0.5. Now what we're going to notice is that the noise is affecting our entire curve, and this is because it's equilateral. So to fix that, we want to multiply this value by our factor. So if I bring in a spline parameter, and a spline parameter, and the spline parameter gives out a factor which goes from 0 to 1 from the start of the curve to the end of the curve, and we can see that that's basically what's happening if I shift the noise a little bit. By the way, if we use 4D noise, we can shift the noise in space. There we go. See how we have made the start stay in place. But what we actually want is not just the start to stay in place, but also the end. So to do that, we would need something like this, a map that goes like this, 0, 1, 0. And to do that, we're going to turn the linear transformation of this factor, which, if we plot this out, if this here is the factor and this is the length of our spline, will be a linear transformation from 1 to 1, or whatever the length is here. But what we want is to turn this into more curved transformation, so basically we're going to want to do this. Alright, which is really just a parabola if we continue it, and more specifically the parabola for this case would be x squared minus x squared plus x. Okay, and then we're going to multiply all of that by some number in order to adjust this maximum value over here. Basically, if this is our maximum value, this is how it's going to function. So let's go ahead and do that real quickly. So all we're going to need is a math node. We're going to plug this in, or I'm temporarily going to disconnect this with control right click. So plug this in here, factor, set it to power. Hold on, let me find power, set the power to 2, shift D to duplicate this math node, connect this here, set it to multiply, and we're going to multiply by -1 in order to flip it. Duplicate again, set this to add, to combine this with the original x, and then this is going to go through another multiply node, which will be basically the strength. So if I then take all of this, and by the way, at this point I would group all of these nodes that are related to the noise with Control G, tab out of that node, and then I can just rename this to smart noise. You'll see why in a little bit why we're calling it smart. Tab to enter again, and then we're just going to continue. Like we said, we want this value to control our map now, or rather our noise. So as I change this, you can see how it's applying the noise only to the middle of our curve. Alright, and it's applying it in all directions. Of course, this is what we want, and the W lets us shift that noise in 3D space. So I want to see my curve, my original curve. To do that, I am going to use a join geometry, and I'm going to place my group input at that point, and now you can see my original curve and the curve that is getting spawned around it. You can see as I increase that, we're getting this very nice arcing thing, which is what we're really going for. We want to basically arc our lightning. However, I would lower the scale even more to something like 0.25. Yep, and maybe boost up the strength. And now we need to talk about one issue, and it is the issue that as this curve gets longer, our noise, the scale of our noise, and also the strength of our noise doesn't really change. But we essentially want the boost, this strength multiple over here, to increase with the length of our spline, and the scale to actually go down with the length of our spline. So in order to achieve that, there's actually a node that gives us access to that information. It's called spline length. Spline length is a value that is just on every point the same. And if I multiply that spline length by this over here, we can now see that as we increase this, we're essentially increasing the strength of the boost. But in order for us to still have some sort of control over it, we're going to need another multiply node right here, and that will actually control the boost and the end. So now the boost is related to the length of our curve. As I'm increasing it, you can see it's curving out more and more. And we need to do this, we need to do the same thing for the scale. However, the scale needs to decrease as we increase the length. So that will be a divide, and in the bottom we will plug in this length. And then over here I would plug this into scale. And now I can control the scale with this value up here and get something like this that looks like it's arcing pretty well. Let me try a different W to make sure that we do have what we want. Maybe I'll decrease a little bit more. Yeah, this is pretty much what we're going for. And as we are increasing this, we can see that now it's behaving more as we want. It's now the scale and the boost are related to the length. You can play around with these values, of course, and you'll be able to also animate them later on for even more precision on this. But basically, we're going to leave it at this, except we want to have controls for this node group, the smart noise. And to do that, we're just going to plug in this value over here, and we will call this scale. And maybe we should be a little bit more specific, noise scale. There we go. And I will also plug in this value over here, which is the boost. I will call this noise boost. And one more for the W, which is over here. And we'll just call this noise W. So now we can control all of these things from out here. There we go. We can control the scale. We can control the boost. And with that, we're pretty much done with the noise. So let's actually talk about what else we need to do. This lightning also needs to fork. You know, lightning, if this is our lightning, it needs to fork out a little bit. And even those forks can have forks of their own. So we're going to do that. Let me just clean this. And in order to do that, we're going to use an instance on points node, which is going to take this geometry of the curve as its points to instance on, and what is going to instance is a curve line, because that is the simplest curve we can make. It has a start and an end. Plug that into the instance and plug this into joint geometry so we can see them, and there we go, our instances on our original curve. So the first thing we're going to want to do, after I save my file really quickly, that works for me, we are also going to want to align them a certain way. So the first thing, actually let's first group this up, because we want this to be a single group that takes in a curve and outputs a curve, and it's called a fork. And I will also rename the input to curve and the output to curve, that because it just makes more sense. And so now that we have our curve, first thing we want to do is reduce the number of these points. We're going to reduce it based on a random number, so a random value. Set this to Boolean, and this is the probability that the Boolean will be 0 and it will be 1. As you can see, if I plug this in, whenever the value is 0, there is no instance there, but if it's 1, it instances something there. So we use this to control the number of forks, basically, and this also has a seed. And yeah, next let's talk about the rotation. To fix the rotation, we want to basically every curve, every curve has a normal that's pointing away from it at every point, and a tangent that is pointing towards it at every point. And what we are going to do is we're going to align our instances with the normal, but also rotate this normal around the tangent a random amount. So to do all of that, we are just, let me clear these doodles, we're just going to spawn in the normal, and we're going to plug it into a vector rotate, and we're going to rotate our normal over here into the tangent. So plug the tangent into the axis around which it will be rotating, and over here we will plug in a random value. So random value, which has to go from 0 to 2 pi, because in radians that is 360 degrees. And then we'll use this new vector to actually align our object using the align euler to vector. Plug vector to the vector we want to align this. Align the z, because this is the direction our curve is pointing at. And then plug rotation into rotation. And now we can see that all of our soon-to-be forks are rotating randomly around our spine, which is great. We can change the seed of this as well, so no issues there. And next up, we need to talk about how we're going to make these a bit longer, because they need to be. It's very simple. We just do a realize instances, which turns these from instances to actual splines, because otherwise they're basically points in space when they're instances. The first thing we want to do is resample them based on length. However, let me grab my resample curve node and set it based on length, where I wouldn't go higher than 0.1. I basically want the same length that is here, so I'll go for that for now. This is because they currently only have 2 points, again because it's a curve line, it has only 2 control points, so we resample it, and right after that we plug in another noise. Actually, we plug in the smart noise that we just created. Alright, but actually before we plug this in, let's talk about the length. They're all the same length. That is a bit of a chore. To fix that, it's really easy. We will just use a spline parameter, and we will connect that up with the mat range, but we will also use the spline length. Okay, so basically if I take the factor and plug it into value, it will remap its values of 0 to 1. That's what's coming out of the factor, which is the factor of the big spline right now, the spline they're all spawning on. And what I want to do is to map this to a length of minimum. That means that the minimum length, the minimum value that will be coming out of this, or rather this node, will be the length of our curve. So in other words, the length of these instanced curves will be dependent on the length of our big curve, which is what we want. So if I then just plug this in right here, we can see that now at the start every instance has the same length as the curve itself, while at the end it has a size of 1, because it says to 1. If I say to 0, then at the end they will disappear completely. And we want to keep this at 0, and the way we're going to be controlling the length of the forks is through these two sliders. As I change the minimum, that changes the length at the start, and the maximum changes the length at the end, basically. That's what we're going to do. I'm going to just leave this 1 for now, which means that there is going to be a length of 0 at the end. Alright, so after that I will finally add the noise by just plugging it in between here, and I will adjust the scale to something that I find reasonable. Same thing with the boost, something I find reasonable. And we can see that just like the big spline, shorter splines get affected less by this noise, which is what we want, otherwise it won't look right. Another thing I forgot to do about the rotation, you can see all the splines are aligned to the normal, but we actually want them, if we look at the picture of real lightning, they're really facing forward a little bit. So we want to tilt all of these residual splines forward. We'll do this with an arrow, align to Euler, and we will align with the tangent. Now you can see whenever they're aligned with the tangent completely, they're facing forward, and 0 they're facing back. Basically we want to randomize this, so plug in a rather random value, which is going to be between 0 and 1 right here. There we go, and now we can see that they're sort of facing forward a little bit more. So what else do we actually need to do? We can actually play around with this size over here. I think they're a bit too big at the start. You can actually change how much they're spread out if you just change this minimum value, if you want them spread out a little bit more, which I do at this point. And then all we need to do is, let me just, yeah, I'm getting confused by the first line over here, so I might just get rid of that, the control line. We can see it in edit mode pretty well, I think, anyway. And then the coolest part is probably because what this takes in is a curve and it outputs a curve again, we can just shift this thing, plug it into here, and just create curves on those curves. There we go. How about that? Now we have curves on the curves we instanced in the first space. However, let's just plug in some controls here real quickly. The first control we're gonna want to have is the count, which is just this probability value over here. I'll plug this in. Another thing we're gonna want to control, I guess, is definitely the length. So I will plug this in, and also this, and I will call these base length and tip length, or just end length. And now if I hop out of here, I should be able to adjust the, or let me hide the second forks with M. I should be able to adjust the base length with M, and indeed I am, and the end length with the second value. Okay, and also this should be the count. Yeah, I can also adjust the count that I'm getting there. So that's pretty good, pretty much something like this. This is already starting to look like lightning, if you ask me. Yep, and then what we need to talk about is actually turning this into geometry, because currently it's just a bunch of splines. If I disable the viewport, they disappear. To do that is very simple, just hit them with a curve to mesh right here, and the profile curve that it will use is a curved circle, if I can find that. Plug that in here, set the resolution to something small, and we'll notice that it's all very big, it's all the same radius, and we don't want that. In order to fix that, actually, we need to set up some radius properties. So that would be before, or rather after the noise. I mean, it really doesn't matter, let's just do it before the noise. We need to set the radius of the curve, because the curve radius is what it's using in order to determine the thickness. So I'll set curve radius, and I want the curve radius to be controlled by the spline parameter. If I plug that into the factor right here, well, you can see it. If I go ahead and mute these and these, we can now see it. Now it's 0 at the start and 1 at the end, that's why it's giving me this shape. Basically we want to run this through a map range node, which will allow me to set up a custom start like 1 and a custom end like 0. This is a bit too thick for my liking, I'll reduce it. And then there we go, this is basically I think everything we needed to do about the radius. Now if we re-enable this node, we'll notice that it's still too big. That's because I need to set the radius for it separately. Let's go ahead and do this after the noise. It really doesn't matter if you do it before or after the noise. Just set curve radius as well. And once again, spline parameter. Once again, a map range. Plug this into the value. And we will just remap this to 0 at the end and 1 at the start. And if I plug this into the radius, we can see that now we can adjust it. Now the radius at the start needs to be dependent on the radius of the spline they're spawned on, okay, because here we see this mismatch and at the end we see they're way too big. To do that, we actually have to capture that as an attribute. So this is the curve that's coming in. If I hit in capture attribute, and if I capture its radius into this float parameter, I should then be able to just use the radius at the start as the driver of the minimum radius, or the radius at the base of the secondary curves, and there we go. Now that works the way we want. They're snapped with the exact length they need to be. And it'd be nice to have a control for this, because usually you don't want the lightning at the base to have the same radius. It needs to be smaller. We'll just modify this with a math node set to multiply, and we'll just lower that a little bit at the base. And it'd be nice to also have a control for this outside of this node, so plug this out here and call it something like radius. Okay, and now we can control that. I can enable the second node, which will also work just as intended, and I would say we're on our way to pretty good lightning. In fact, the only thing we need to do now is maybe play around a little bit with the base radius. Okay, and also maybe increase the secondary forks a little bit. Yep, we can do that. Maybe just give a little length to the forks at the end. There we go. Same over here, I suppose. The end length. Although the tier 3 forks are really thin, so I don't know if you can even tell. Maybe decrease the base length a little bit. Really, I'm urging you to play around here. Alright, so the last part, I guess, is a little bit of noise, because currently this is way too perfect. They're way too smooth, and lightning is very noisy. To do that, before we actually turn this into a mesh, we'll take all of our joint curves and we will plug them through a smart noise. However, this will be slightly different noise. I will click this number here to make this a unique node and rename it to just noise. Because unlike the other noise, this one will not be dependent on the length. So go ahead and plug that out. And noise scale just directly controls noise scale. And the same over here, where we don't want this. Okay, and then noise boost just directly controls the boost. So now we want this to be very fine, so very large amounts, something like 25 on the noise here, and we can see that we are getting something. Maybe play around with the boost. However, I'm not saying I don't have enough resolution on my initial curve. I will fix that just by changing the resample to 0.1. And then over here I will change the scale, or rather I will change the boost. There we go, something like that. In fact, I might want to change the noise a little bit, change the boost. And I also need to change the sampling on my forks, probably give them the exact same amount, 0.1, in which case they get really rowdy. But again, that is something we're going to change using the boost. The final noise boost, I suppose. In fact, if I disable that, yeah, just got to change the noise here until we have something we're comfortable with. Okay, and honestly, I think I just have too many secondary forks. I would lower this to something like 0.1. There we go. That's more sensible, because remember that the number of forks it spawns depends on the resample count. So keep that in mind. As I just increased it, it just gave me a lot more forks. So I would need to reduce this number quite a bit. Yep, and now I think we're pretty much done. If I just take this, I should be able to move it around. Yep, it's coiling around, it's giving me more lightning. I can have any shape for this. You know, I can change the start and end of everything. Everything's set up. I have a seed here and here for the rotation. Yep, here's one seed, there's another one. So you can really change these things here. What I would recommend having a control for more than anything is the W of this noise. So plug that out. And now I can control this from over here. And if I just have a single value driving all of this, or why don't I just use the group input? So this value driving this W, but also it will control the W over here and over here. In my modifiers tab, I will now see this, and I can just control the W, which just makes the entire noise, the entire lightning just kind of dance around. And you can animate this, of course, so feel free to do that. You can see how it's generally following our curve, but it also has a little bit of character to it, like it coils around it a little bit. And of course you can control all of this. Also, what control would you like to have? Maybe a control for the seed of the way they're spawned. So that would be the probability over here. Just plug this seed into here. And in fact, I would probably have this seed control every randomness. So over here and over here. Where else do we have randomness? Well, nowhere else really. So I can now change the lightning. This is the forks. You can change these forks as well. But honestly, I would have these under a single banner. What I mean by that is a single seed controlling all of these, just like that. And I guess where else do we have random distribution? Nowhere else. And now I have it over here. I can just control, and Blender crashed. Oh no, I don't think I saved. Oh, this isn't very good. Let's see the damage. Let's just see the damage over here. This is what happens when I don't save a lot. That's it, right? Okay, we did lose some progress. That's okay. All I was doing is I was just plugging things out into the output and showing you how you can control multiple things at once. And it seems I lost all the progress on the noise. But I think we were there anyway. So I'll just skip that for now, and I'll just show you how to continue this. Basically what you need to do is set a material after the curve to mesh, and your curve you want to give it 2 materials. So the first one is just the one it's gonna have, and then the next one will be the actual lightning. So I would rename this to lightning, and I can just plug this into here, or I can plug it in with the group input. It doesn't matter. And then if I just go into the shader editor, I change it to render view. I go ahead and turn on the bloom. I should be able to make sure you're on the lightning in your shading editor. Increase the emission to maximum, change the emission strength, and if I hide the viewport, which is done with this button up here, you can now see your lightning. And I think it looks fairly convincing. It doesn't have the noise because Blender crashed. I lost that, but yeah, you should be done. I'm trying to think of what else could be done, but there's really nothing. I can show you how to animate this because it's really easy. You need to use a plugin, so go to Edit, Preferences, go into Add-ons, and type in Anim. You see Animate All, enable that, and if I bring out the timeline from underneath over here, set it to timeline, and bring out the menu on the right hand side, go into, I guess, Animate All. I can then go into Edit Mode and click points, so it's adding keyframes for the points. Make sure on the first frame and click Insert. Go somewhere else, pick this point out, move it, click Insert, and now it should be animating. I might not have clicked Insert at the start though, I don't know. So this should be that, and over here is another point. Oh, I had selected only. I need to insert a point for all of them. So insert here, and yeah, there we go. Now you can just animate this curve as you wish. You can also animate the W, the seed values like I showed you. Can I make this look better? Yeah. So have fun with this. Honestly, this is the tutorial. I think this was much shorter than the last one. Just a quick note here, I forgot about this. If you plug a trim curve between the resample curve and the set curve radius of the initial curve, you can actually sort of trim our curve from the start, and you get this very cool animated effect where the lightning is just sort of popping out. So I wanted to add that. It's really cool. And also, if you just want to draw curves like I did in the video, all you have to do is be in edit mode of the curve, and then there's this draw button which will allow you to just draw any shape for your lightning. Okay? But yeah, tune in next time where I'll show you how to arc lightning within a single object, which is slightly different from everything we've seen so far. And with that, I think we'll end the lightning tutorials and we can move on towards something else. Okay, thanks for watching and bye.